Similar to the previous section, now we have the area under curve with respect to the y-axis instead of the x-axis. Firstly, we have the area of a region to the right of the y-axis. The area bounded by the curve x equals to fy instead of y equals fx. The y-axis and the lines y equals to a and y equals to b is represented by this definite integral. So this shaded region. Then we have the area of a region to the left of the x-axis. This case is similar to the one in the x-axis, whereby the area is under the x-axis, so the area is negative. Likewise, the area on the left side of the y-axis will also be negative. Therefore, once again, you have to add the modulus sign or the negative sign to make it a positive area. Please note that in order to solve questions where you have to find the area with respect to the y-axis, you have to make x the subject of the equation, because now all the equations will be x equals to fy instead of y equals to fx, like previously. Therefore, when you do integration now, you'll be integrating with respect to y instead of with respect to x. Now we'll look at the example 15.2. So we have a curve x equals to 6y minus y squared and the line intersecting at a and b. Find the coordinates of a and b. So we'll be using simultaneous equation to find a and b. You have your equation 1, which is just the equation of your line, and your equation 2, the equation of your curve. So we always sub line into curve. So we'll sub equation 1 into equation 2. And then you end up with a equals to 0, 6 and b equals to 5, 1. Part 2, calculate the area of the shaded region. If we observe this shaded region, there's no way that we can do a direct integration from this coordinate to this coordinate, because we'll account for extra area again. Therefore, we'll need to split this whole area up. We'll split it here, whereby on this area on top, we'll label as A1. You can see that it's once again the area of a triangle. And for A2, we'll then use our integration to find A2. To make our lives easier, let's label our coordinates first. So A is 0, 6 and B is 5, 1. Okay, let's start by finding area A1. So the triangle is simply base of 0 to 5 and a height of 1 to 6. So for the base, you'll be looking at the x coordinates of B, and then for the height, you'll be looking at the y coordinates of A and B. Therefore, it's half times 5 times 5, which is 25 and over 2 units square. Now for A2, we'll be doing our integration to find the area between the curve and the y-axis. In this case, the question is nice enough to give you the area of the curve by making x as the subject already. But if the equation given starts with y equals, then you have to make x the subject yourself. So now we'll form our definite integral. We have an upper bound of 1, so the y coordinate of b and 0, the y coordinate of this point. Then we have our equation of our curve, and then instead of dx, we'll have dy because we're integrating with respect to y now. Then we do our usual integration within our square brackets and bounds outside of the square bracket. Sub in our upper bound minus our lower bound, and you'll get 2 and 2 over 3 units square. Now to find the total area, we'll simply sum up A1 and A2 to give us 15 and 1 over 6 units square. In summary, when you're doing questions that require you to find the area between the curve and the y-axis, there are things to look out for. Firstly, your equation of curve must be in terms of x. So x equals to whatever. Secondly, when forming your definite integral, your bounds are your y coordinates. Lastly, instead of writing dx, like how y'all may be used to, it is dy.